Welcome to Tollefson Physics. So what we're going to do today is we're going to use Google Sheets as a graphing tool. And so in this particular case, I know I have linear data ahead of time. I'm going to show you how to enter that into Google Sheets and how to draw a best fit line. And then ultimately, how do I come up with a meaningful equation? So this isn't going to be y equals mx plus b. It's going to be whatever there is that we write on each axis. So let me switch over to our sample data. And so what I have here is I have some position time data similar to the experiment that you're doing for the ramp lab number 1. And so what you need to do is you need to open up a Google Sheet. You can do that from Google Drive. And then what you have to do is we have two columns of data, and it's very specific on how you put this in the spreadsheet. And so for a position time graph, position always goes on the vertical axis and time always goes on the horizontal axis. That's because the meaning of the slope has to do with something. And so I'm going to plot it that way. So to be able to plot it that way, whatever you want on the horizontal axis goes in the first column. So that's what I entered here. And at the top of the column, I actually enter the name of the variable, and I put in parentheses the units that it's measured in. So as you can see here, I've entered time in seconds. And so then so presume that I'm measuring this object that's moving, and every 2 seconds I measure its position. So the position ends up being the dependent variable, and that is what I want on the vertical axis. Now, if you ran your position and time experiment where you were measuring how long it takes to get to a certain spot, that's fine. We're still going to plot it with time on the horizontal and vertical and position on the vertical axis. Here I've got position, it's measured in meters. It's very important to have units because I could have done it in centimeters, I could have done it in inches, I could have done it in feet. So you get the idea. So this is how you first have to set it up. And usually I'd set this up at the top, but I put these things up there to remind you that what's on the horizontal axis goes first, what's on the vertical axis goes second. When you name a graph, by the way, it's position time. It's always what's on the y versus what's on the x, because what's on the y is what you're measuring. Okay, so now I'm going to highlight my data. And most of the time in this class, you're only going to highlight 2 columns of data. You'll get some funky stuff going on if you get multiple columns. That's a more advanced skill. It can be done, but for our purpose, we're just have one set of data points. Well, there's 2 ways to do this. You've always got the picture bar up here, and there is a insert, although it might be off my screen. There it is. Insert chart button that you can push there. Or if you can't find that, you can always go to insert and chart. All right. And so what it will do is it will come up and it will try to do something. And usually it tries to do the wrong thing for our purpose. We want a scatter plot. And it looks like there's an update, so we'll see how that changes our process. But I'm going to click on chart type, and I'm going to switch to scatter chart, which in this case is a suggested one. If you don't see it up there, you just scroll down until you find scatter and the dots, and that's the kind of graph we want. So you should only have one color of dots. If you don't have one color of dots, something's not set right. And so typically it's these things down here that aren't set right. So I'm using, in this case, row 4 as my headers. What does that mean? Well, those are the names. See how position and time are on the graph automatically? I don't have to type those in, so that's kind of nice. And then for whatever goes on the horizontal or x-axis, that is going to be called a label. So those 2 boxes have to be checked, and usually they're automatically checked. If they're not automatically checked, that's one way to troubleshoot your graph. All right, so that's the only thing we need to do on the setup part. Next, we're going to go over to customize, and then this is where you can write all the different things you want. Now, the nice thing is it already picked up position versus time. I didn't have to type that in separately. And notice, it used the default setting. It's the vertical axis versus the horizontal axis. So that's normally how it's done. It's normal to spell out the variable name, and then you can use an abbreviation for the unit. If you need to change any of those, there's chart and axis titles, and you have this little drop down which will allow you to switch. So it was on chart title. If I want to change the horizontal title because I did something wrong or it didn't pick it up automatically, then I could type it in there. But in this case, it worked. Okay, so what I really want is a line of best fit. And so to get a line of best fit, I'm going to click on series. And if I don't like blue dots, I can always change that. I'm not going to do that here. What I'm going to do is scroll down, scroll down, scroll down until it says trend line. I'm going to click on trend line. It draws a line through it. So it's automatically going to put in a linear line. And what we're going to be trying to do in this class most of the time is we want lines. And if we get a curve, we'll do something else to try to change that curve into a straight line. Okay, so now what we're going to do is we're going to go down to label. So I keep scrolling down because I want the equation of that line. That's what I really care about. So I click on label and I go to use equation. And the weird thing about Google Sheets is it actually doesn't give you a full equation, right? You would expect something that's y equals mx plus b. Well, the y is missing. It's missing. All right. So what I will typically have you do in your lab reports is I'll have you just type what the equation of the line should be using proper variables for position and time. And in this class, for one-dimensional position, we're going to use x for horizontal motion, and we're going to use t for time. And so actually, I'm going to type it just over here just to show you an example. So we are so used to using y equals mx plus b, right? And so what that equation up there means in that language, y equals 0.05 times x plus 0. Okay, so what we really want to do is we need to rename y. Y over here is position. And so, like I said before, we're going to use X for position. All right. Then we're going to figure out what the slope of the line is. So I'm going to put 0.05. And for the slope of the line, it has units. So don't forget, slope is rise over run. So rise over run, the units for rise are meters. The units for time is seconds. And so I'm going to type meters divided by seconds. That's the rise over run. So that matters because if I had done this in miles per hour or something else, I have to know that. This one is in meters divided by seconds. And then I'll multiply that by the x-axis. And in this case, the x-axis is t. Now, in this particular example, my intercept is 0, so it's kind of unnecessary to write 0. But the units for that 0 would be what is on the vertical axis, which would be meters. But I did idealize data, and so that fit. Now, for those of you that want to go the extra mile, you don't ever have to do this. But once you know your equation, you can actually go back. Here's 3 dots, edit chart, customize. And if I go back to series and I scroll all the way down and change it to custom, I can actually type that equation in. But I kind of have to write it down so I know what I'm typing in. So I'm just going to copy what I just wrote, meters per second times time. Oops, missed that, times time, and enter. And now this is the real equation for that straight line. Okay, so that's it in a nutshell. That's how you create a line of best fit using Google Sheets. All right, so hopefully that works out for you. And if you have any questions, let me know.